Alright, in this video I'm going to talk about how to draw Lewis dot structures. So I've got a copy of the periodic table up here so we can see the elements, and whenever they become ions, their charge difference and everything. And I'm just going to start a little bit with covalent Lewis dot structures, and then I'm going to do some ionic, or not ionic, but some diatomic Lewis dot structures as well. In fact, I think I'm going to start maybe with that. Let's do nitrogen here. So we've got nitrogen on the periodic table. It's group 1, 2, 3, 4, 5. It wants to receive 1, 2, 3 electrons to look like neon. So it has 1, 2, 3, 4, 5 valence electrons, nitrogen, and then when it's at the diatomic stage, it's N2, right? So nitrogen has, the first one has 5 valence electrons, the second one has another 5 valence electrons, so therefore it has 10 electrons total. So our Lewis dot structure here for nitrogen should have 10 electrons total. If it doesn't, then we've screwed up somewhere. So basically all there is to it, and this is kind of what a Lewis dot structure would be if we were just going to, I'll maybe just draw nitrogen first. We were just going to draw nitrogen, has 5 valence electrons. You would just have 5 dots around here. 2. So that's 5 dots. 2, 4, or no, it's not. That's 6. Oops. So that's 5 dots right there. So that would be kind of the Lewis dot structure for just nitrogen by itself. But we're going to draw it in the diatomic state. And it goes to the diatomic state because basically it wants to have all 8 valence electrons. There's this octet rule. Maybe I'll write that in a different color even. There's an octet rule. And it's a rule, not a law, because this only works, some of the time. There's many occasions when you'll find valence electrons where there's more than 8 valence electrons. That's why it's a rule. But it's a pretty good rule, and it works for a lot of elements. But in the diatomic stage, there are 2 nitrogens. So we have our 2 nitrogens. That's coming from the N2 right there. And we know that there has to be at least a single bond between the 2 atoms. And a single bond between 2 atoms, let me draw it separately over here, is going to look like that. It'll have 2 dots between them. This is a single bond. Actually, let me even draw it in a different color up here so we've got it as a reference. This would be single bond. This would be what a double bond would look like. Make that a little bit bigger there. This would be a double. This would be a triple. One, 2, 3, and you can kind of get the idea of where that goes. This would be a triple. Triple bond, okay? So, that being said, we know it at least has to have a double bond in between them. And we know that we have to use 10 electrons total, right? So we've got 2 there, so we can just go and add the rest of them throughout here and just see if it works out. We've got 2, 4, 6, 8, 9, 10. Alright, so we've added 2, 4, 6, 8, 10. The rest of our electrons just kind of aimlessly throughout our Lewis dot structure. And we know that because of this octet rule, that this nitrogen wants to have 8 valence electrons, and that this nitrogen wants to have 8 valence electrons. So let's kind of take a look here and see if it's worked out. So we've got 2, 4, 6. This nitrogen is sharing these 6 electrons, And then I'll even do it in a different color here, maybe a blue. This nitrogen has 2, 4, 6. It's sharing those 6 electrons. So it's not 8. It's not going abiding by our octet rule. So we must have to go up to either a double or triple bond. These nitrogens need to share more electrons in order to have a full octet. So let's start over with it here at a double bond. And got nitrogen, nitrogen, and let's just do a double bond. So we've got 4 electrons used there. 5, 6, 7, 8, and 9, 10. We'll just stick them there for now. So we've got all 10 electrons used at this point. Let's take a look at our octet rule here and see if this worked out with the double bond. So these electrons are sharing those, and grab a different color. Go back to my magenta. That's 2, 4, 6. So that hasn't gotten our octet yet. Over here we've got 2, 4, 6, 8. So this one's happy, but this one's not, because they both have to be at an octet, right? They're diatomics. They're coming together so that they both fulfill their octet. So we must have to go on to a triple bond at this point. So let's do this again. We've got, and let me scroll down even just a little bit more so you got more room, can see. Nitrogen, nitrogen. In our last bond we had one. Oh, let me switch colors. In our last bond we had one here, one here, one here, one here, one here, one here. We had them over here and over here. This nitrogen had 6, this had 8. So we need to get a triple bond. And I just need to take 2 of these 10 electrons here in order to do this. It wouldn't really make sense for me to take these 2 over on this nitrogen because it's lacking 2 electrons to fulfill its octet. So I want to add to it, not take away. So I want to take these 2 electrons and put them right here and right here to make an octet. So all I'm going to do are move these right here. Maybe I'll even overlap them in a little bit of a different color so you can see that we're moving these to right here. Draw a little arrow right there. Those electrons are moving to right there. So that makes this nitrogen have 6, 7, 8, and then this nitrogen has 6, 7, 8. So now they're both happy. So nitrogen, whenever it forms in a diatomic instance, has a triple bond, and they share these electrons in between. That's what a covalent bond is. It's the sharing electrons. So that is nitrogen, and I think we might even have time for one more. Let me scroll back up here. That was nitrogen that we just did. Let's do an easier one. Let's do hydrogen. Let me get rid of some of this over here so we can see a little bit better. Now, hydrogen kind of follows the octet rule, except it's only, well, I guess it really doesn't follow the octet rule because octet means 8 valence electrons. And hydrogen and helium are really only satisfied with 2 valence electrons. So hydrogen in the diatomic form is going to have 1 valence electron for the one hydrogen and 1 for the second hydrogen. So it's going to have 2 total. So 2 total. Let me scroll down so make sure you can see this. 2 valence electrons total. So we've got a hydrogen here and a hydrogen here. and they're going to be held together by at least a single bond, right? And we know that we have to use 2 valence electrons total. If we don't, we've messed up somehow. Held together by a single bond. I've used my 2 valence electrons, and now I'm done. This hydrogen is going to share those 2 electrons. This hydrogen is going to share those 2 electrons, and it's happy. That one was a little bit more easier. Nitrogen's a little bit more harder, but nitrogen in the form of a triple bond is going to be about as hard as it gets, and you kind of get the idea of how you just kind of keep working through. You start with single, move to a triple, double, then to a triple bond in order to get your octet rules satisfied. In the next video, I'm going to talk about compounds a little bit more, how to write Lewis dot structures for compounds, and even some helpful tips and rules and guidelines you can kind of go by that will save you some time on writing out these Lewis dot structures. So anyway, thanks for watching. Hope it helped.